Hi friends, here we are given P, Q, S and R. P, Q, S and R, they are on the circumference of a circle with radius R. And there is some circle which is of radius R and these 4 points are on the circle such that PQR is an equilateral triangle. PQR is an equilateral triangle and PS is the diameter. Right. Then what is the perimeter of the quadrilateral PQRS? Right. Obviously, we should derive the perimeter in terms of R. Right. Now, here we are given PQR is an equilateral triangle. PQR is an equilateral triangle. What does that mean? This angle is 60 degrees. Similarly, this angle is 60 degrees and this angle is 60 degrees. Right. Now, this is diameter. This is PS is actually the diameter. Right. Here, because this is equilateral triangle, this angle is 60 degrees, right? This is 60 and this is also 60. The triangles on both sides, that is PQS and PSR or PRS, these two triangles, they are congruent. They look congruent. But just by looking at them, we should not say that they are congruent. They look congruent, but we should actually prove them also. Right? How do we prove that? This side PQ is equal to PR. Why? Because these are sides of equilateral triangle, which is PQR, which is already given. At the same time, the angle in a semicircle is 90 degrees. That is PQS. This angle is 90 degrees. Similarly, PRS. This is also 90 degrees. Right. So PQS is equal to PRS. Similarly, PQ is equal to PR. PQ side PQ equal to PR. Similarly, side PS equal to PS. Right. It's the same side, same diagram, right? So two sides equal, one angle equal, and also because this is right angle triangle, this side should also be equal to this side. Why? Because hypotenuse square minus PS square, PS square minus PQ square is equal to QS. Right. So that means this side is also equal to this side. Right. All three sides are equal. So we can prove in multiple ways that these two triangles PQS and PRS are congruent. The same hypotenuse and same side. What does that mean? The third side is also same because these two are right angle triangles. Now we are sure that these two are congruent. Now, now what we have to find? We have to find the perimeter of this entire quadrilateral. Now, because these are congruent, what does that mean? This angle is equal to this angle, right? This angle will automatically become 30 degrees. This also will become 30 degrees because the total is 60 degrees, right? And now this is a right angle triangle. What is tan 30 here? Tan 30 is SR by PR. Or in fact, what is sine 30? Sine 30 is RS by PS, right? RS, which is opposite side by hypotenuse. Right, sine 30 is half, we know. What is PS? PS is diameter. And RS by PS is half. What does that mean? RS is actually equal to radius. RS is equal to radius. So similarly, QS is also equal to radius because radius by diameter is half. Right, this is also equal to radius, this is also equal to radius. Now we just need to find what exactly is this so that we can calculate the perimeter. What is this again? This again What is tan 30? Tan 30 is 1 by root 3. Right. If this is x and this is r by x is equal to 1 by root 3, then x is equal to r root 3. Right. This x we can write it as r root 3. If this is r root 3, this is also r root 3. So we are left with what is the perimeter? 2 into r root 3 plus r. 2 times r root 3 and 2 times r, which is equal to 2r into root 3 plus 1. This is the final perimeter. Right. So here we are given a equilateral triangle, which is obviously symmetrical or congruent on both sides, but we have to prove that also. Right. And we can prove that very easily because this is already given as height as the diameter, and then these two sides are equal. What automatically means the third sides are also equal because it is right angle triangle. This square minus this square under root of that will give the third side. Once that is proved, then it becomes straightforward. Right. We just need to use this tan 30 and sin 30. Right. Thank you guys.